until now, we've been emitting RBD pieces from an animated curve path. So let's change this up for something more interesting. In the previous basic concept number 1 video for Perk 2 members, I added in some footstep crushing ground scene into the Houdini project files that was given away only for Perk 2 members using the RBD emission. The fun part was that I used the footsteps to drive the emission source points for the RBD emission and create fake debris, as if the character was crushing the ground while he ran across. In this video, we're going to do something similar, but instead of using an animated character, I'm going to use a simple ball bouncing animation that's powered by a sine wave. This way, I can keep the scene a little more focused on the RBD emission because that's the topic of the video. The truth is that there are so many applications for RBD emission. The stuff that I'm showing you in these videos are just a few simple ideas and how you can apply it to your own scenes. Basic concept number 5, RBD trigger points. Starting straight from the previous basic concept number 4 video where we had a bunch of RBD fractured pieces swapped into the RBD emission scene, but we're still emitting from a curve, which isn't very interesting. In this video, we're going to set up a more advanced way of triggering the emission to create a more interesting effect. So let's take this. Now let me delete this. We're not going to use this curve path. Let me show you what it looks like. This is the curve path that we're going to delete. We're no longer going to use this guy. Let's call this RBD emission points. Let's drop down a sphere. Turn off the points. Put the render flag on the sphere. We're going to make this ball bounce. Now we can accomplish that very simple sine wave. The transformation, I'm just going to add a sine wave to the y-axis. So I want the ball to move up and down. Sine powered by the frame. Okay, let's play it. Ball goes up and it's a little slow. So let's change the speed. Let's make this like 4 times as fast. The sine wave is driven by the $F here, which is the timeline. So if we make the timeline faster by multiplying a number to the frame, the $F, the whole sine wave will move faster and the animation will move faster. Now we have another problem. It's going through the ground. Because the sine wave has a negative value as well, it goes positive, goes up, and then goes back down to the negative areas. We don't want the negative areas. I want the ball to bounce. So I'm going to add in an absolute function. Make all the negative parts positive. So ABS, let's play it. I'm going to speed this up a bit more, multiplied by 6 instead of 4, even faster. If we look a little closer though, put the viewport into front view. The ground is actually there. So let's play it. It's actually going through the ground right here. We're going to have to move this up a little bit just because the sphere starts off in a bad position, which is right on the origin and it's through the ground. So let's move this up a bit so that it starts off in a nice state, aligned to the ground. Now the sphere is 1 by 1 by 1 because it has a radius of 0.5. So we know that it's a 1 by 1 by 1. In that case, we can just move it up half a Houdini unit. So let's go this transform. I'm going to call this align to put the render flag here. I'm just going to move it up by 0.5. And you can see here that it's aligned to the ground. So now we're going to put the render flag on the sine wave and let's see. So now it bounces right there. So we have our animation. We need to detect the bounce, but we also need a plane to emit from, something to emit from. We only want it to emit RBD points when the ball bounces on the ground, when the ball comes into contact with the ground. So let's put in a grid to represent our ground. I need a bit more resolution for the grid. So let's give it 200 by 200. So we have plenty of resolution. I'm going to use something called an attribute transfer. I'm going to transfer some of the attributes from the sphere, from the ball, onto the ground so that when it comes into contact or close enough, that attribute will get transferred to the ground and we know when the bounce happens. First of all, let's create an attribute to be transferred. So let's drop down a wrangle. You can actually use an attribute create for this. I'm just so used to using this. I'm going to call this I at contact equals 1. So I stands for integer. I'm just going to create a simple integer attribute in the points attribute, and I'm going to call it contact, and I'm going to give it a value of 1. So let's take a look at the geometry spreadsheet. All of the points on the ball has a contact at point attribute with a value of 1. Now we're going to transfer this attribute onto the grid. So let's drop down attribute transfer. Now the first input of the attribute transfer is the geometry you want to transfer to, which is the grid. So I want the grid to end up with the contact point attribute. So the grid actually has to be in the first socket. And then where do I want to transfer from? Well, the ball. Okay, let's play it. Well, we can't see anything because this is all playing in the background. So what we can do is drop down a color node, and I'm actually going to color the contact. So this is going to be black because this is only for visual purposes. We're only checking our work. Now point class ramp from attribute because we want to color points based on the contact attribute. So we're going to choose contact down here. And I'm going to choose a different color though. I want to choose black into orange. Okay, that looks good. So everything is orange right now. That means the whole thing is being transferred. The whole grid is receiving the contact attribute, which is not correct. Let's template our sphere to see where it is. And you can see that it's really close, but if we go up, when it's up here, the ground should be black because it's not even close. Let's see what's going on in here. I forgot to transfer the attribute for one thing, but the contact's not being transferred. I didn't choose the attribute. So down here, drop down contact. And another thing is that let's go to the conditions tab up here. And it looks like the distance is set way too high. It's 10 Houdini units. So that's too much. First of all, let's put the render flag onto the color node so we can adjust this distance threshold while seeing it on the screen. And I'm going to adjust this down. Okay, and instantly we can adjust it so that it fits. Well, right now the sphere is not even close. It should be completely black on the ground. So let's play it. Okay, this is not right either because it's close. So let's make this 0.1. Okay, and let's step through this. Okay, that's pretty good because that is actually touching it. And then it gets orange, which makes sense. Not in contact, not orange. Contact? Okay, this is perfect. So it bounces, bounces, bounces. And every single time we have that orange contact, we want to emit RBD pieces from this. So we want this to contain RBD emission points. Okay, let's zoom back out. Let's look at the rest of our node setup. So we're using this ball bouncing animation and we're going to replace that curve and it's going to feed right into our RBD emission point. So if you remember correctly, in the curve animation, we had a point that was being animated along the curve. We need to convert this orange area into certain points. Well, that means I don't need the rest of the grid. I don't need the black colored parts of the grid. So let's drop down a blast node. And let's blast away the darker areas. Delete non-selected. I'm going to choose points. And I'm going to keep the ones with the contact with a value 1. So @ symbol tells Houdini to read in the point attribute because we've chosen point in this group type. And what attribute name? Well, contact is the attribute name. And what is the value of the attribute? 1 that we want to keep because I have this delete non-selected checked. So what happens? Okay, there we go. So the darker areas are gone. We're left off with just when the ball bounces, this area will be filled. Now you can actually just use these points, like these points. You can just use these points if you want. What I prefer to do though is scatter some. That way it's more random. You'll have a little bit more variety. Now the force total count, I don't want 1,000 points. That's a little too much. Let's just start with 3. This global seed, it's 0 every single time. So let's take a look at where our points are in mini. We have, let me make this a little larger. Okay, so we have 3 points here. Fast forward the timeline to when the next bounce happens. The points are still in the same spot. Okay, let's go to the next bounce. Okay, it's still in the same spot. So you can see that because this global seed value is not changing, the points are being scattered in the exact same spot every single time. We want a bit more variety to make this a little bit more interesting. So let's put in a different seed value for every single frame. Well, we can easily do that by just feeding in $F. That will give it a different seed value every single frame. And let's see how this works. Let's move on to the next bounce. Fast forward the timeline to the next bounce. Okay. So you can see that the points have indeed moved. So they're different. They're being scattered randomly, at least more random. You can also relax the iterations. This will give it a bit more variety by unchecking the relax iterations. This gives it a bit more space between each other. If you uncheck it, sometimes they get cramped together, like this one over, like these two over here. It gets really close together. That might look a little more interesting in some certain cases. Usually for scenes like this, I would keep this unchecked. So now we have our emission points. Now let's hook this up. And let's just play it and see what happens. Okay, that's not very fun. I want these RBD emission pieces to look like debris. So when it bounces, it actually bounces up, because that's what debris does. Newton's third law, every action has a reaction. The pieces should fly up. Let's give our RBD emission pieces some initial velocity. Now we can add in initial velocity right over here. Let's add in some initial velocity over here. Give it an attribute randomize. Attribute classes points, because we're dealing with points. And I'm going to change this to V for velocity. And the operation is set value. Perfect, because it's a new variable. We don't have a V. And over here, well, distribution, it is a direction and orientation. It's a direction. So dimensions 3, perfect. Cone, well, this is the angle that you want to randomize it to spread across. Well, 30 degrees, that's fine for now. We'll fix that a little later. Well, the direction I want is the up direction. I want it to go upwards, so somewhat upwards. So let's put it for the Y. Well, I want to see what is happening first. So let's fast forward the timeline to when the bounce happens. So let's put some velocity markers. Let's come over here. And this is the variable that we want. Click this, V, and it'll create the velocity markers. And you can see instantly we have some velocity. Now it's being spread over the 30 degree angle. Let's make this a little wider. So let's go 100. Okay, so this is a bit wider. Let's come over here back to the RBD bullet solver and let's play it. Now I gotta fix that first bounce too. Okay, you can see that the bounce is happening. Not what I really want. I want it to be more spread out. So let's start off with lowering the scale. Come over here and I'm gonna lower the scale because the pieces are way too big. So this range is starting from half to 1. Well, it's way too big. So let's go down to 0.1 to half being the max. So we're shifting the entire range. Let's see how this looks like. Okay, it's still one thing, it's still too big. Okay, let's lower this to 0.3 and the minimum to 0.01. It's super small. Let's make this even smaller. Seems really large. The reset. Sometimes when you're fiddling around with the P scale, because this is being fed into a copy to points and then implicitly is fed into the RBD solver, when you update this node over here, sometimes it won't trigger the RBD solver to update. You can see that I'm not getting cache frames. It's still just giving this out. In that case, come over to the RBD solver and just hit the reset simulation button to kickstart everything, because I want it to get the newer points. And there's another thing, the ground. In the previous setup, we had the ground moved a bit lower. You can see that this is the actual ground that the ball is being bounced on. But the ground that we're seeing in the RBD solver is down here. So you can tell that that's why the pieces are falling down here. And it's going through the ground as well. So there are a lot of things that we have to deal with. We have to fix up. Okay, let's go over to the RBD solver and let's actually lift it back up or put the ground back to the normal place. And that's in the collision tab. Let's come over here. Let's return this back to normal. So let's revert to defaults. Okay, that looks a bit better. Now let's play it. Okay, I know the pieces are going through the ground, so we have to fix that too. Now, why are the RBD blast pieces going through the ground? Look at it. It's swimming under the ground. That usually means that there's something wrong with our RBD setup. Now this was all working. Before we had all this put in, this whole setup was working fine. So could it be something that is wrong with the ball bouncing animation and the orange area, the bounce detection that we put in? Now what has changed from the last time from that animated curve in comparison to this ball bouncing? Well, for one thing, the animated curve only had 1 point. It was only emitting 1 RBD blast piece per frame. This time we're emitting 3 blast pieces per frame. Let's start with that because everything else was working fine. So let's take a look at a suspected culprit when we randomly choose the RBD piece, the type attribute that we had created. Let's take a look at this, where all the decision making for that randomization happens. Okay, let's fast forward to a place where we have points. Here, points, moving close. Let's look at the type. So we have a type here. Go down. I'm going to turn on the marker for the type. So I'm going to turn this on, type. Let's take a look. Hey, what's up? This is 25, 25, 25. It's emitting the same number. It's the same blast piece being copied in. Well, that would cause a problem for the RBD solver. Why? Let's take a look at the RBD solver. Copy to points, which feeds into the RBD solver. I think I have to go to the next bounce. There's something wrong with the first bounce. We'll fix that one a little later. Okay, so this is the next bounce. We have the 3 blast pieces. Let's take a look in the geometry spreadsheet. The issue is here in the name of the points. They're all the same pieces because we're saying, okay, I want 3 blast pieces with the type value of 25. Well, that means we're going to get 3 identical RBD blast pieces. In the RBD solver, it cannot handle 3 pieces having the same name. That's not good for this. For one thing, I don't want to emit 3 of the same blast pieces every single time it bounces. That defeats the purpose of having a variety of different pieces. Of doing all this, it's all about variety to create more interest. So let's go back to this wrangle and randomization. Let's take a look at this little piece of code, these 2 lines. Well, I'm choosing a type value by randomizing each frame. I'm getting a random number each frame, and I'm getting a result between 0 to number of pieces, 0 to 25. Sounds good enough, right? But wait, this is running on each point. So we're having 3 points. We're getting the same random value for all 3 points because this wrangle goes over all 3 of these points. And the only thing that's driving the random value is the frame. All 3 points have the same frame value because they're all emitting on the same frame. We need another number here. We need a different number here to drive the random value. So we can have a random value for each frame and for each point on each frame. What we can use is the point number. That's not going to be enough. Like, we can't just replace the frame and go pt num. That's just going to give us a random number for each point, but not for each individual frame. So every single time it bounces, it's going to have the same random number. It'll be 3 different pieces, but it'll always be the same 3 pieces, which is still not what we want. We want even more variety. We want different pieces on each bounce, but every bounce to have different pieces. So we want a combination of the at frame and the at point number. What can we do? Just multiply it. It's going to bounce on a different frame. It's bouncing on frame 60. And here's the next bounce, it's frame 90, and the next one is different. So the frame's always going to be different. If we multiply that with the point number, it's going to have a different point number. Well, except for the first one. It's 0 based, so you have to be careful with that. There will always be a point. The first point number is always 0, so you're going to have to add 1. Anything multiplied by 0 is just 0, and we want variety. We want something to be different. Okay, let's get this first in. At frame. Multiply point number. Now this gives us mostly what we want, except for one of the pieces will always be the same because one of the pieces has a point number of 0, and anything multiplied by 0 is just 0. So that's where we have to be a little bit tricky. The at point number, we're going to add 1. So we're going to move it out of its, shift everything over. So we're never going to get the 0. This give us something more random. Let's take a look at what we get. So you can see this is 22, this is 1 and 20. Let's move this forward to 120. Okay, 7, 2, and 3. So that's pretty good. It's different. 24, 15, and 12. I think that settles it. That gets us what we want. Let's zoom back. Let's take that out. Take out this. Okay, let me make the background darker. Okay, now we've solved, you can tell that this is not going through the ground anymore because we fixed that naming issue. It's now giving us a different RBD piece for every single point. So it's not, the bullet solver cannot handle 2 blast pieces with the same name. So we're getting unique names. Now, I would like it to bounce higher in the blast, so it's not flying up as much, it's just showing up in the ground, which is not really what I want. We can try to fix that by increasing the velocity. Now, we had an initial velocity here. Initial velocity. We can increase this, the scale. Let's give it something crazy like 10 and see if it does anything, just to check, just to see. Okay, that's too much. You can see it fly off. Let's do 5. Okay, still too much. Let's give this 2. Oh, I don't think the RBD solver is being updated. You can see here on the bottom, this is blue frame. It should turn orange when I change this global value, but because of this implicit chain being connected into the RBD solver, it's not triggering it to update. So we have to manually come over here and reset the simulation. Let's give that a try. Okay, that's a bit better. It bounces. You can see that little bounce. That's what I really wanted. We can make this a little bit even more by adjusting the initial velocity again. I'm gonna make this like 3.5. Let's try that. And come over to the RBD solver, reset simulation. Okay, that's much better. Yeah, that looks nice. And we can even do something even more to push this. Go to the scatter node and we can increase the number of points. So let me change this name. Number of pieces. Let's increase this to, let's say 10, and then come over to the RBD solver again, reset, play. Okay, that looks a bit better. So you can have a lot of fun with this. So this is just one way how you can use this RBD emission. Have you ever created a complex RBD destruction scene breaking an object? Sounds simple at first. What about those nice tiny debris pieces that break off to give that realistic touch to the RBD effect? It gets costly when you add in debris details. Using RBD emission for faking the tiny debris pieces is a lot more efficient. This works if your project doesn't require a hyper-realistic destruction scene. When using RBD emission as your debris, the pieces aren't actually coming out of the fractured object, but creates an illusion that it's fractured from the object. Thanks for watching and sticking to the end.